Welcome again to the Southwest Climate Podcast. Mike Crimmins, how you doing?
Hey, Zack, monsoon season. Couldn't even say it.
It is. It's a big episode day, right? We've been what now? A month? Can you believe it? A month. So we're coming at everybody. We're recording this on July 19th. It'll probably drop early next week because this is a Friday. It feels like we've been in the monsoon for a long time. This is our first monsoon podcast, really. I mean, we did the monsoon preview. But buckle up, Mike. This might
Yeah.
go on for 2 hours. We got a lot to talk
Don't threaten people so early in the podcast.
about. We'll cut it down. We'll cut it down. At the end of the episode, it'll be 75% Mike Crimmins,
Nobody.
20% Zack, and 5% just random noise.
It'll be 15 minutes. That's right, of content.
All right. So what we want to do is get everyone caught up on the monsoon, do a tour of the stats, talk about its evolution so far, a little bit about what's on the horizon, what we've been learning so far. How does that sound, Mike? You ready?
Let's do this.
All
It's
right.
monsoon season.
Okay. So let me just start this off, though, by giving a quick shout out to the Power Forecasting Group at the Arizona Institute for Resilience, because they produce what is a fantastic monsoon forecast discussion daily, believe it or not, even on the weekends. At least I think it comes in on at least on Saturday.
Yeah.
Uh, but no, it's a great resource. It's technical, but even if you don't know things like decape, which we may talk about later, you can get the big picture relatively quickly, and it's also a great resource to learn. I mean, I use it to help me figure out oh, I need to bone up on this. It's pretty cool. So that comes out, like I said, daily, and you can you can get on that list by sending an email to our colleague Patrick Bunn, and we'll put his email in our show notes, and just send a note that you'd like to be on the monsoon forecast discussion, and you'll get that email every day. And so just to give you a preview, so this is from today, that came out about 30 minutes ago, and I'll paraphrase. This is just one snippet. The relatively favorable monsoon setup combined with near to slightly above average moisture will promote monsoon activity through the weekend and into early next week, with storm coverage, timing, intensity dependent on day-to-day variability. And then they go on to explain a little bit about what the conditions are. And it's usually focused on the next day and a little less on 2 days out. So it's a daily read. So kudos to them. And yeah, like I said, we'll put Patrick's email in the show notes.
Yeah, we'll also put a link to it. You can, if you don't want to sign up, you can throw it in your bookmarks. And yeah, it's fantastic. I think us.
Oh, that's a good point.
Yeah, our monsoon
web page. Yeah.
I'm a consumer of all the Weather Service forecast discussions, and love having this in the quiver as well.
So, Mike, if we were to do this pod last year on this date, the monsoon would have basically just begun.
Yeah, that's right.
And now, and we'll get into this, we're close to 30 days into it.
I know, and I was gone for about a week and a half of it, and I still feel like it's been going on for months already.
When were you gone?
Right over the 4th of July, and
you missed the break of it. Well, and we'll get into the evolution.
We did, but I apparently missed a tornado in Tucson, which had trouble stringing those words together.
Yeah. Can you imagine? That was South Tucson, right?
Yep.
Okay. All right. So we're going to unpack the evolution. I'm going to cue you up, Mike. But let me summarize the data so far. Okay. So we're going to do a macro version first. This is always difficult to describe the spatial pattern here. So you have to envision a map, Arizona, New Mexico. So I'm going to describe the precipitation pattern looking down, let's say, on Arizona, New Mexico. So as is always the case in the monsoon, there's these areas of above average precipitation, these bullseyes, if you will, surrounded by usually larger averages of below average precipitation. That's like a classic pattern in the monsoon. Those areas are highly variable. They change from year to year. So this year in Arizona, the above average bullseyes are between Sierra Vista and Douglas in Southeast Arizona, around Tucson, around Casa Grande, a bit outside and to the north of Phoenix, a larger area around Flagstaff and Prescott, and in the Four Corners region, both for Arizona and New Mexico, and much larger for New Mexico. Okay, so that's Arizona. And then for New Mexico, it's a bit more scattered, and a large area of above average rainfall extends from the Four Corners south to Gallup and all the way east to Albuquerque and Santa Fe. And then there is a whole bunch of smaller areas in the northeastern quarter of the state. And then the rest is, near average or below average. So we'll also post that map a link to that map in the show notes so you guys can see that. In general, roughly 50% of the two states have near average, slightly below average to above average. Just how Mike, it's your figure that I'm looking at, and you sort of do this categorically.
Right.
Near average is, what is it? 75% of average to 125% of average is near average.
Yes. So there's below is below 75, near average is 70 to 125, 75 to 125.
Right. So nearly 50% right now of Arizona and New Mexico are 75% of average or above. Okay. As for the 5 cities we track, Tucson, Phoenix, Flagstaff, Albuquerque, and Las Cruces, all but Las Cruces is above average. And so this picture, variable as it is, was greatly impacted by the early start of the monsoon, right? So if you look at traditional definitions of the monsoon, like we talk often about this, the dew point definition, which is a measure of moisture in the air. Right. That was like 2012. It was the classic definition. You had to have 3 days above, 54 degrees Fahrenheit dew point, right? Like if you look at that definition, which again is a measure of moisture in the air, the monsoon started on June 23rd. So June 20th, no, 21st.
21st, yeah.
It was above that average. And those values persisted right through July 5th. And then there was a break, which we'll talk about in a minute. So heavily influenced by an early monsoon start. So Mike, maybe you can, with that sort of setup, let's talk a little bit about like what the evolution of the monsoon looked like from its onset to where we are today.
Yeah. So there's a lot of wringing of hands, mostly by me, I think, right? The last podcast. And boy, I'm glad it broke this way. And it really, what happened was pretty unforecastable, I think, right?
So the wringing of hands was because there was an expectation of below average July precipitation, let alone, although we have to go back and also recognize that there was indication in the shorter term forecast. I'm remembering from our last podcast of like tilted chances for like the 6 to 10 or 10 to 14 day of like enhanced chances for above average.
Right.
We did recognize that, but I actually think I was more sure of the dry start than you were. But
I think you were.
We can both claim the wringing of the hands. So.
Well, I think that your monsoon fantasy, which we'll talk about later too, is your guesses probably reflect the forecast better than I do. I had a lot of optimism and wish casting that was going on, and for months the global climate models we were looking at the National Multi-Model Ensemble and the International Multi-Model Ensembles, which are the big international efforts and national here within the US that can give us forecasts out months to seasons. We're suggesting that June and July and the whole season was going to be below average. And so we, May, looking at the June outlook, no indication that we would see anything kind of early or even near average. The expectation would be below, and hitting below in June means it doesn't rain, right? So that's not like that. That's just how statistics would work. So we ended up, I think the last time we talked, there was just all of a sudden some hints in the models right at that point, looking out 5 to 10 days, that, oh, maybe there's something a little bit on the horizon. And the activity in the Gulf of Mexico with this expectation for a really bonkers Atlantic hurricane season, which has also been quite interesting, kind of manifested. And we had a hurricane. It was a hurricane, right?
It was not. It was tropical.
Just tropical storm, right? Okay, tropical storm Alberto. Given the position of the mid-level high pressure system, which was really over the central part of the country at that point, big heat dome, baking everybody, heat wave. That tropical storm was perfectly guided. Well, mostly its moisture was perfectly guided on the south side of that ridge, and that would have put it on a northwest trajectory towards the southwest. So from the Gulf of Mexico across northern Mexico and Texas. And we literally had a wave. I don't know if you remember this, Zack. There was there's the really devastating fires in New Mexico with Ruidoso, very hot, dry conditions. And this literally wall of humidity passed through Ruidoso right at, this is a couple days after the official start of the monsoon on June 15th, and turned into, popped up some thunderstorms and turned into flash flooding. So they've had just absolute extremes there, from very, very extreme fire weather conditions to flash flooding right there. And that was really the beginning of this wall of moisture that was basically the onset of the monsoon this particular year. Was this event that we ended up having the dew points rocket across much of the Southwest, rocket up 20, 30 degrees Fahrenheit, and then hang out there for at least for a week in the later part of June. And we set daily dew point records here at Tucson anyways. And if you looked at precipitable water, which you can measure from a balloon sounding that the Weather Service does, there was a day or two that the precipitable water record was set as well for that kind of third week of June. So that was our monsoon onset, which was really an event, which was related back to this guidance of tropical storm moisture into the Southwest.
So let's unpack that a little bit. Okay, so the setup, right? Like, we tend to think of the monsoon as, the classic, the canonical sort of four corners high, sets up over the four corners and allows like moisture to sort of come in from the south. That's actually not what happened here. Right?
That's right.
Classic situation is plays out sometimes, but doesn't always play out. And in this particular case, you had a broad ridge of high pressure that was off to the east. I don't know where it was centered, but like its western extension was sort of into what, Mike? Into New Mexico, or was it Texas?
Well, it was a pretty broad ridge over the Central Great Plains and into the eastern U.S. That was about the time too there was a big heat wave over the eastern U.S. And so everybody was talking about that. And interestingly, there's a weak trough of low pressure that has been hanging out over Southern California, had been kind of leaning into Arizona, and that's not good. That's no bueno for the monsoon start. And so
that would suppress the northern expansion of the high pressure, right?
Yeah, it's basically the kind of the boundary between the maritime tropical moisture, which is the tropical air mass, and this kind of more continental dry air mass that would have been to the northwest of us. And so that the monsoon is always a battle between this hard edge of very dry interior desert air, which is usually over like Southern California, kind of rides up through Las Vegas. Las Vegas is usually on the edge, curves around into southern Utah, and that's the kind of the northwest boundary of the whole monsoon when you're in it. And usually that boundary is over southern Arizona in early part of June, and you're really waiting for that progression of that tropical air mass up into the southwest, which is guided by all these kind of upper level features.
Okay, so we had this broad high pressure that was more off to the east. Right? That's perhaps not all that uncommon.
No, this is
in and of itself.
Yeah, no, like it looked like June. It looked like June on a weather map. Yeah, it looked like June on a weather map.
The feature, however, that was in combination with that was the tropical storm Alberto, which was...
So the Gulf of Mexico, record sea surface temperatures, record kind of low level relative humidity, moisture readings, and the positional high pressure system, and then the organization of that tropical storm, just this like giant bolus of moisture that is able to kind of move in a direction if the upper level pattern is favorable. And you and I talked, remember the very last thing we talked about on the podcast last time was like what does an enhanced Atlantic season do for us? And we're geniuses, right? I mean, we're prescient, totally prescient. But yeah, I mean, like we were super lucky. Like that's a crazy way to jumpstart the monsoon, is to reach into the Gulf of Mexico, to have this moisture come all the way across.
If you look down on Alberto, though, it had like this huge fingerprint.
It was massive. Yep.
I mean, it wasn't it wasn't a hurricane, right?
No.
But like the moisture was like hugely expansive. I think it's central track went in my Mexican geography. It's central Mexico, more or less. But there was also like disaster declarations all the way up to like Galveston, Texas.
Yeah, past Galveston. So the extent, it was quite disorganized, had some weak circulation, broad area of thunderstorm activity. So yeah, I think that's a good point. If it was a real compact, tight circulation and storm, it could have wandered off in kind of any direction and may not have been, particularly impactful up here in the Southwest. But yeah, it was really interesting to see. I mean, because you could watch on the satellite and actually watch on the surface observations the jump in dew point that would occur from east to west as this, moisture traveled towards the Southwest. And it was really quite impressive.
So the combination of these two things was what was rare.
Yeah.
Do you remember, has this scenario sort of set up? Because it seems like these were the two main ingredients, like the large tropical storm in a particular place, but also the steering flow, the high pressure, which, sort of was moving, clockwise rotation, if you will, funneled that moisture into, the Southwest.
It's not super uncommon to actually get that flow where you can actually get, so New Mexico, for example, will have recurving tropical storms from the Gulf of Mexico every couple of years. And those are the big, there's the flooding events they'll come across.
But this early.
That's the key. That's the thing that stands out. That's usually kind of like that's like, so again, this event in the Atlantic was quite early, right? In the Gulf of Mexico, it's really early, right?
Yeah.
And everybody in the kind of hurricane forecasting has been advertising for months now that, things are right to really pop. Yeah. And again, those sea surface temps in the Gulf of Mexico are crazy high.
Yeah. The forecast were really, really active Atlantic season. Some of the highest forecasted hurricanes, tropical storms that I've ever seen, if not.
Yeah. I think they're the most like bullish numbers that I've seen in a long time. But yeah, I really, really lucky. And again,
lucky.
Well, lucky for us.
Oh no, I'm sorry. Lucky because we I mean, who doesn't? Well, I shouldn't say who doesn't want an early monsoon. Certainly Ruidoso probably
Probably that was,
did for
yeah,
that particular event. It's a mixed bag, right? Like it
it,
probably quelled the fire.
yeah,
The fire had already done the damage, but like the rains were and the humidity were a suppression of that. But of course,
yeah.
they led
It,
to
they didn't have
flash
containment.
floods.
They
Yeah,
didn't have containment on that fire prior
yeah,
to this huge jump in humidity, and they still struggled with it because it was a big fire, and then the flooding is, hugely impactful. So it was a disaster on so many fronts for them. But we were struggling with um, ending the fire season here because of the heat, kind of middle part of June. Interestingly, but the evolution of this is interesting too, right? Because this big wave of moisture persists, and then the monsoon pattern is really quite mediocre for the end of June. It's normal because it's still it's very early for that, but it's mediocre if you've got all this moisture sitting in there. And we ended up losing a lot of that moisture. It just kind of got scoured out and pulled out of the region, and the dew points in the moisture source started to drop, and we had a big break across much of the Southwest. Right, it was kind of early. Well, it was. I know we had some spotty thunderstorm activity kind of around July 4th, but then it really bottomed out kind of the second week of July.
all right, before we go there,
Mhm.
because I think there's like, three phases to this, the first month of the monsoon. And then what you're going into is the sort of dry phase. So let's go there in a minute. But I just wanted to unpack a little bit like June. Because like I said, there was a lot, like you said, actually, there was quite a bit of precipitable water around, some of the highest values on record, and that was not just Tucson. That was also, Phoenix had really high dew point temperatures, Flagstaff, like all across the Southwest. Tucson Airport had a little bit over an inch of rain, but that doesn't tell the whole story. Like if you go to rain log and just look at the June 15th through the end of the month, first of all, I had at my house, I'm close to downtown. I had 2.2 inches on one day, right? Like
Wow.
I don't think since I've been living there for 15 years, I think that's the biggest event. I don't have official records, but like I cannot remember an event that big. But real close to me, it's on the order of for June, like 3 inches across the metropolitan area. Out east, there's a lot of 2 to 3 inches. Out west, there's 1 to 3 inches. It gets a little bit drier as you go further north in Tucson. So, you know, at the airport, there was an inch. And if you just look at the airport over the history and ask yourself, okay, well, how many times did we get this amount in June? It's not a lot.
Not a
It's not
lot.
unprecedented, right?
Yeah.
So at the airport, 2024, 1.07 inches at the airport comes in fourth most behind 2016 had 1.6 inches, 2000 had 1.56 inches, and 1954 had 1.46 inches, right? So we don't have rain log back on those, so I can't do those kinds of comparisons. But I do think I was pretty sure in my mind that June was going to come in at the most rainfall in Tucson on record. It doesn't at the airport, but again, I think it sort of belies what actually happened because the airport was on the lower side if you look at the metropolitan area. I will say when you look at rain log and you look at sort of Phoenix did not experience it like we did. There is some rainfall there, like quarter of an inch to a half an inch in a number of places across the metropolitan area. Like the most of it was sort of in the north part of the city, northeast part of the city, but certainly not to the degree of Tucson, and that's what you would expect, really. Flagstaff and up north, again, looking at rain log, fewer rain loggers up there, but still some data points. Like they got 2.5, 3 inches up there in some parts. So, like pretty vigorous June, better than you can't expect anything better than that.
No, and if as you were kind of describing the maps earlier on too, the that event, that huge kind of jump in moisture that came out of the east. I mean, the Four Corners and much of New Mexico, they saw some rain. I mean, they saw a lot of rain for June. Like Gallup ended up having, numerous. They had a couple of back-to-back days with daily precip records right around that period of time, and our Gallup already just into, what are we, 30 plus days into the monsoon season has 2.66 inches of rain. And, at this date, they should see about an inch,
Yeah.
So
I've got Albuquerque from June 15th through the end of the month had 2 inches of rain, and that was fourth on record going back to 1951. And it was also like, it wasn't just one event. There was 7 days of measurable rain there.
Yeah.
So there was quite a bit of activity. So I guess before moving on, we started this with the expectation was for dry, and we didn't really see it coming. If we didn't have this event, would the models have verified? If we didn't have this setup,
yeah,
right? Like if the tropical storm, let's say, didn't occur, right? Or maybe it was further south. Like, would we be standing having a very different discussion? We would be, obviously.
I think so. I think we'd be where we were last year. And I think that the June model would have verified, because if you look at the position, so the evolution of the position of the subtropical high, the kind of the Four Corners high or monsoon ridge, it wasn't great. It wasn't even great, a couple days after we had that monsoon, that moisture work into the region. And there wasn't real good mechanisms to get rid of it once it got in here. And so if it hadn't kind of bullied its way into the Southwest, the broader pattern wasn't going to get it there probably any other way. It wasn't a great setup for good Gulf surge activity, where the position of the high was kind of suppressed. It was hanging out over Arizona, New Mexico. It was hot, right? So we had a lot. It's been very, very hot here, even with the moisture in place. Sometimes that you'll get a little bit of reprieve with more cloud cover and stuff like that. So it kind of tells the story. I don't think if we would have got that slug in there, we would be in a good spot. And it was interesting because maybe you're kind of working this way, Zach, with a combo, but those precipitable water records, looking at some of the Tucson data from the balloon soundings there. So set a couple of records. So on Wednesday, June 26th, so this would have been after that wave came in here and we were kind of in the thick of that tropical air mass, we set a record of 1.83 inches of precipitable water. That was for the afternoon sounding. And so and it really hung out there. So by Tuesday, July 2nd, we set another record, 1.91 for the day. That was 2024, 1.91 inches. So it's like, that's hanging out there. But it's interesting because if you kind of follow this forward, by Tuesday, July 9th, we set another record for the driest precipitable water on record for that date, which was 0.59 inches. And so we had that tropical air mass effectively kind of got scoured out
but it took a long time. So I guess this is a question. Like, why did it take such a long time to get scoured out? I mean, again, from June 21st through July 5th, the moisture around the area was way above or average.
Yeah.
Right? So, I mean, that's hanging around for a long time. And if we're sort of, was it all from the tropical storm sort of setup here, or was other things going on? And I guess the question is why did it take so long to get scoured out?
It's the maddening thing about the monsoon is that the flow is weak. There's very little advection. And so advection is the horizontal movement of air, right? And so if you live in the Great Plains, you're used to, that's like cold fronts sweeping through and they drive up supercells and you've got a huge, humid air mass, and all of a sudden it's replaced by a cool, dry air mass and all that kind of stuff. We don't have that. So as soon as if you're underneath a high pressure system and the flow is weak, it's stagnant. And so it was stagnant. And so what scoured that moisture out is that the whole upper level pattern started to shift around, and it happened right about July 4th. Is that there was a broad trough over the eastern US, and the upper level high was actually building out over the East Pacific. So we were in a broad northwest flow, and the northwest flow for Arizona, it does not matter what season it is dry. And so that there was now a bit of advection, and it was that dry, continental interior desert air mass started to work down into the southwest, and
Yeah,
it dried everything out.
and that, yeah, so that marks the sort of second phase. This is the dry period that really began around the July 4th and persisted for 8-ish days or so. But just going back to what you said before about the stagnant, I mean, there's a little bit of another idiosyncrasy here, right? Like because it could have been that the atmospheric pattern was such that moisture from Alberta was scoured out much quicker.
Yeah. Oh yeah, totally. But it's like it that would have happened if we would have, okay, there's a couple of situations, right? So I think if we would have had, which would be totally uncommon, is what if we had one of those like deeper troughs drop in, which was hanging out there. If we got a strong trough that dropped in there, it could have very quickly shoved that moisture off to the east, and we would have been just back into kind of the normal.
And then that would remind me, and I have no idea if this is an analog, but do you recall, when was it? 2018?
Yeah.
Hurricane, no, was it Hurricane Bud or
it was Hurricane
Bud?
Yep.
Yeah.
East Pacific. Yep.
And I think on June 15th,
yes,
we got a bunch of rain from that, but it was like one day.
It did, and it was confusing to all the precip stats, because it was like even kind of falling over midnight, whether you counted into the monsoon season or not. But it was exactly that. So we call these transition events, where you've got a trough off to the west, and ahead of a trough you can have southwesterly, southerly, even a little bit of southeasterly flow, and that's good this time of year. It can drag stuff up. But we had a recurving tropical storm that was interacting with the dynamics of this upper level trough. In it, we had some widespread heavy rain right at the beginning of the season. But I think where you're going, Zach, is that really it wasn't the monsoon, right? It was monsoon season. It wasn't the monsoon in the sense that the tropical air mass was being kind of pulled up into the southwest in a more permanent way because of the position of the subtropical ridge. And so that had somewhat similar characteristics to this year, because the dew point gradually dropped over the following weeks, and we didn't have the activity pick back up again until kind of second week of July, I think.
Yeah, I think it's just interesting, like, a retrospective on the monsoon onset, like how many of those onsets could be characterized by that sort of classic monsoon, what you think of the monsoon, right? Like the ridge in a particular position. And then how many of them were sort of instigated by the sort of randomness of weather, like these events, I don't know. What's your guess on the fraction there?
Yeah, well, the early ones are almost never the typical monsoon ridge position, because that's an evolution. That climatologically doesn't usually move into position until beginning of July, right? So that we have this very.
So what, are you saying though then that every onset there's a triggering event for every onset?
Yeah, probably. I mean, well, to get. It's a good question, right? I'm trying to think of, like, is there an easy? Yeah, I think so. There can be a slow build, right? So the canonical kind of typical monsoon, like if you're gonna like do the conceptual model, right? You'd have the upper level ridge, subtropical ridge, the monsoon high, all the names we got for it, is going to progress north. It's usually kind of over New Mexico. It's going to kind of move up into the four corners in its mature spot. That typically is happening through July. And so remember, south of that, you're going to have flow out of the east. And the idea then is that there's easterly waves and triggering events and just moisture, more moisture available in Mexico. Those large clusters of thunderstorms have outflows, and those outflows will flow north. This happens in Arizona quite a bit. Kind of at the beginning, you'll wake up and there'll be all that kind of humidity in the air all of a sudden. And that's not because it rained locally, it's because it rained in Mexico and all that moisture, right? So you can, and then you might get an actual Gulf surge of moisture where you've got real true advection of that low level moisture up into the low deserts of air. Again, this is very Arizona centric. The New Mexico kind of path and journey is a bit different. It's, moistening up from Gulf of Mexico moisture over there, but also has outflows from northern Mexico and Chihuahua. So that, you get that slow build and then start to kind of sustain it. But it's, I was talking earlier today about this. The monsoon is like a huge collection of like 2 to 3 day weather events, right? And it's like a deck of cards, right? The whole deck is the monsoon season, but you can look through it and it's like all of this different kind of combination of weather scale events that make up the composition of the climatological things that we talk about. The climatological way we talk about it are just abstractions of all these weather scale events.
Well, let me ask it in a different way. If you were to do sort of a classification exercise for the onset,
yeah,
how many similar patterns do you think you'd get? How many similar, how many patterns of onset conditions would you get, if that makes sense? Do you follow what I'm saying?
Yeah. And it kind of depends on, okay, so like, we're talking the Southwest writ large, like across the whole Southwest. This could be tricky too, because it's
no, let's confine it to Southeast Arizona, like the heart of the fringes.
The heart of the fringe, right? And so that would extend into Southwest New Mexico as well. So
Correct.
it's like
Correct.
Right.
Yeah. But let's leave out like the core of the monsoon in Mexico.
Sure. That's a good question. It's not hundreds. I think it's like, in my experience, like less than a dozen, maybe 5 or 6 kind of different.
Yeah, that's interesting. Yeah. I mean, you got these different flavors, right?
Yeah, I think that's right. I mean, there's not like there's fundamentals. The high pressure system is going to be somewhere.
Right.
It's going to be around somewhere. And so that limits the kinds of weather events that you can get. I mean, there's the tropical storm type stuff that can be at the beginning. Again, it's like we can be lumpers splitters here too, right? Like those kinds of transition events aren't technically, you get precip out of them, but they're not technically the monsoon, kind of a mature monsoon where you've got this, upper level wind direction shift and moisture that's come into the region with it. I mean, it can be part of the beginning of it, which is, I think, what we saw this year, but it's almost like it's just this week that we've seen kind of like, okay, now it's starting to look like the typical monsoon pattern across the Southwest.
Okay. Let me just summarize, because this is the third phase. All right. So we had an early onset, and then we up till about July 4th, and then we had a break that was marked by the sort of high to our west that was driving sort of dry airflow from the north down. Right.
Yeah,
that lasted and the dew points dived.
Yeah. Yep.
And then I'm forgetting the dates here, but maybe at the beginning of this week, is that when the sort of position of the ridge sort of moved to the classic more Four Corners area, and marking the onset of like the third phase, if you will.
The building, after we hit that really low precipitable water on the 9th, the ridge started to build back across the southwest, a little bit more familiar to what we'd see this time of year, kind of starting on the 10th and 11th. And it really, like the event that you had at your house is like, okay, we're like, that's kind of in it. And so it's interesting. You called it a break. And I think that's right. But if we didn't have that June event, I mean, this is stupid
Yeah.
obvious. It wouldn't have been a break. Like
Yeah,
this,
we would have had a late onset, in other words.
yeah, this would have been the onset.
It would look like last year.
Yes, this we would be in onset right now. Like, yeah, it'd be an after July 4th, later than average onset across the Southwest. But it's to your point is like, well, how many in that catalog of years were actually driven by these same? Probably a lot of them. Probably a lot of them.
Yeah. Should also say that it's been pretty dang hot.
It's been really hot.
Despite the rain being around, right? So
Yeah.
June, statewide temperatures for June for Arizona and New Mexico were the warmest on record, 130 years according to NOAA. So that's June. You can drill that down a little bit. The Four Corners region was if you look at sort of sub-regional, that was the warmest on record, and in southern Arizona was much above average. So it was driven by the Four Corners for Arizona. Minimum temperatures for June were record across virtually the entirety of New Mexico. Not so much for Arizona. So yeah, so it was and I have also, I guess, looking at just July now. So that was June, so record June temperatures. And then if you look just for July, let me call this up. Past month, show rankings. Boom. Lot of like number 1 values, number 2 and number 3 values across Arizona. Less warm across New Mexico. But Tucson, for example, 5th warmest. Let's see what else. What's number 2 here? Carefree, number 2. Phoenix, Arizona, warmest on record. Flagstaff, warmest on record. So it's been dang hot, Mike.
It's been dang hot. And it's interesting, July will probably come in bad too. I'd be interesting to see if it looks similar to last July, which was epically bad. I mean, we've got some time left, and the temps have moderated as the precip has flared up across the state a little bit more. But I mean, it's really got to get cranking here to take the edge off the temps here for this month, the way it started off, anyways.
All right, so I want to pivot a little bit. So going back to that map that I was describing initially, the above average precipitation map for Arizona and New Mexico. So, okay, so in my mind, I was thinking of the monsoon as, given the amount of moisture, its earliness around, I was like, this is going to be a really good picture across the state. And, as I mentioned before, like, a majority of the area is below average. So that was providing a little bit of a dissonance for me, right? And then another feature on this map, like the Four Corners is sort of the area that has experienced, in above average terms, the most rainfall, the most, relatively speaking. And I'm just, do we believe this? And I think this gets to the question of like a persistent frustration for me is we just don't have a lot of like spatial coverage of the monsoon. And like what we use are these interpolated data products. And I don't know, Mike, what's your take on like, what do we believe this? Like, is this presenting a false picture?
Well, which part? Like the fact that it's dry some places and wet other places, or
no, we definitely believe that. That's
right.
We don't need data to
Yeah,
to
I know,
that.
right? Yeah.
But I guess it's like what I'm asking is, do we believe the when we look at the maps, do we believe that the Four Corners a large spatial area has experienced rainfall up there? And do we believe that, given that we have observations in, relatively infrequently, do we believe the spatial coverage that we're often presented with, right? Like, or the bullseyes that I was referring to before, or are they more, are we underrepresenting the above average conditions, or are we getting it pretty dang close?
I think we're doing all of the above. I think that in some places,
Can't have it all the above.
well, that's the problem here is that the maps are, an aggregation of uneven coverage of actual observations, right? That's the dirty little secret. It's not really a secret. It's out in the open, but I don't think if if you're wading through the data, you understand how. So in this happens all over the world, right? But especially here in the US, and especially in the Western US, the cities are oversampled and every place outside of the cities is undersampled. And so we can do amazing depictions of fine scale precipitation patterns in like Tucson and Arizona, or Tucson and Phoenix, because we've got flood control gauges, we've got home weather stations, we've got volunteer observers from things like CocoRa's and Rainlog. And so from block to block, we can
Flood control districts.
absolutely, right? So all of those gauges, right? And then as soon as you get out to remote areas, maybe there's a fire weather station, maybe there's a more rural flood control district gauge, maybe there's a volunteer observer, but then the data coverage goes way down. And so when we look at maps, especially the statistical interpolation gridded products, there's a lot of guessing that has to happen. That's the inherent nature of how an interpolation works, is that you're going to use whatever data you have, and you're going to take 2 points and you're going to try to come up with a relationship that you can somehow figure out from the elevation of those gauges, and then try to paint the mountains in, that because we know, well, it should rain more at higher elevations. That's typically how it works. But in the monsoon, we have lots of days where the valleys will get more rain than the tops of the mountains. And so doing it here in the doing it, in the south, mapping precip in the monsoon season over the Southwest is very, very tricky, and we really do our best.
Yeah, it's like just frustrating. And I don't have a solution for it. Just want more and more spatial coverage.
You just want to vent a little bit, don't you? Yeah.
I do. Well, also, the radars too are set up for the
Yes.
urban areas. And you can use that, and many people do. But there's blockage, right? Like, so the radar beams get blocked by topography. And so for Tucson, for example, you can't see, this more than I do, like headed toward like cells, that area is like blocked from the radar that's set up. And then, yeah, like that's common, I guess. So that's another sort of urban bias, if you will, for the data.
Yeah, I mean, this is a climate issue, right? It's that we don't actually have many climate specific monitoring networks. I can only think of really one that was designed for climate monitoring. That's a climate reference network. And there's only like a couple of dozen of those across the country, right? And they've only been out on the landscape for about 15 or 20 years. Every other network of data that we use, like co-op observers, that wasn't really designed for long-term climate monitoring. The airport data wasn't really designed for that. We've got volunteer networks, which is great, but those are volunteers. They can't, we can't have observers live for hundreds of years, which would be handy, but that wouldn't be it. And the radars are designed for monitoring severe weather over populated areas. And so they've been plopped all over the country to make sure that their scans are covering the most populated areas. And so the one in Tucson is on the Empire Mountains, and that mountain range is lower than the surrounding Catalinas and the the Santa Ritas and then some of the mountain ranges out to southeast Arizona. So as it scans around at its lowest scan, and the lowest scan is the scan you want to see what's coming out of the bottom of a thunderstorm. And then what you can do is you can use some relationships with the radar reflectivity to estimate the rainfall rates, and then you can total those up over time. So that's one of the ways that we actually now monitor surface rainfall is through radar estimation. And it is super helpful and useful because we can make out very fine scale precip patterns, but there's a lot we know that we miss. And those precip patterns can sometimes over or underestimate what truly falls on the ground. So the only way to really know if a location, how much precipitation a location has gotten is a rain gauge. And we don't have rain gauges everywhere we need them.
So what's your best guess though when you look at these, and a lot of these gridded products, like they try to assimilate all the data that's available, right? Like, or not all of it, but like it's not just looking at it's much more complex than just taking a ground station and then doing like a simple linear interpolation between the two places. They're assimilating radar data. They're using what we know about relationships between topography and relationships between, bodies of water, if you're close to the ocean, for example, or a large lake, right? So, but in terms of the Southwest, it's even accentuated, the challenge is accentuated when you have high spatial variability in a phenomenon like the monsoon.
Yeah.
So I guess my question though is like, and I don't know if there's an answer to this, but like in looking at like the best available gridded products, which tell us information, it's not worthless. There's a lot of value there, but do you think we're underestimating or overestimating the amount and coverage?
Well, okay. So I produce two different sets of maps with two different data sets. And the prism is probably overestimating the spatial coverage of the above average areas. And then the other maps I make, which are using the NOAA multi-radar, multi-sensor MRMS, multi-radar, multi-sensor data, is probably underestimating precip in some areas with beam blockage. And so it's almost like if you look at both, you're going to get similar but slightly different, and so you almost kind of have to mentally try to bring them together. And this is something we've talked about. Maybe there's ways of, this is an active area of research, and there's even remote sensing ways of kind of trying to track thunderstorm precipitation as well, but probably some hybrid approaches that will get us a little bit closer from these different data sets. But again, it's still very difficult. If you really want to know where it rained in a spot, you need to have a rain gauge. And climatologically, though, that's the challenge, is that when you put a new rain gauge in a spot, you actually don't have the climatology because you've only collected the data. So there's other ways to try to get around that problem as well.
All right, I think we just lost like 50% of our...
I do. It's so boring. I mean, it's like I live and breathe this stuff, and I have multiple rain gauges in my backyard, but that doesn't help anybody.
Let's take a quick break from our sponsors, then come back and talk about what we've learned. Have you ever wondered why forecasting the monsoon is so difficult? Have you ever wondered if you can forecast the monsoon? Now you can test your guessing skills in the Southwest Fantasy Monsoon. Yep, there is such a thing. And it's harder than fantasy football and March Madness, particularly if you continually pick the University of Arizona team to win the finals like I do. All right, I'm just kidding. We have no sponsors. We're not that popular. I just wanted to give a plug for the Southwest Fantasy Monsoon game. It's not too late to sign up. In fact, this year we're offering monthly prizes, gift cards, and there's still 2 months left. So if you haven't tested your ability to guess or forecast the monthly rainfall totals across the Southwest, you can still sign up. And you can check that out at monsoonfantasy.arizona.edu or just Google search Monsoon Fantasy, and I'm sure you'll find it. So yeah, that's our plug. We're still having a great time with it. So check it out. All right, and we're back, Mike. So final segment here. What have you learned so far from the monsoon? Every year, something comes up that's like, I didn't think about this before, at least for me.
Yeah, so it's funny, I had an idea and then I think we talked it out earlier. And it
Oh, you
was,
did?
well, it was like, I kind of talked about the idea that the monsoon really needs to kind of progress north out of Mexico to kind of help bring that whole tropical moisture north and help kind of sustain the deeper moisture here. And this year surprised me because we didn't do that. We just jumped over that, right? We jumped over that, but it's caught up with us. And so, even though we had that good jump start, we're kind of getting back to square one and doing it the old-fashioned way over this past week. And so I think it still holds true. But yeah, I think like that whole discussion we had about the onset is that, I hadn't thought deeply about that before. And so it's like you never count out this how weird the start of a monsoon can be down here.
Yeah, that's a good one. So for me, I paused on the question, and I'm a little embarrassed to say this, but I'm like, why doesn't it rain in Yuma? And
Oh
so
yeah, yeah.
what led me to that though is the early onset. And I'm like, yeah, we just need moisture around and you let the sun do the work. Right. And if we can get moisture in the area and late June, we're gonna have monsoon. And then I'm like, well, wait, that's not really the case because if you look at the dew points and the moisture around Yuma and they're pretty high and it's bloody hot there. So why the heck doesn't it rain in Yuma?
Is that a question of the universe or
Question to you.
a question? Dang. All right. Um, I I think it's because okay, so this is the do we even say SQT today or sounding or
We
any of
have
that kind of
not,
stuff?
but go
Okay,
ahead. Yeah.
right. So the thing that the monsoon nerds, I think there's many of you listening right now. You've probably heard us talk about, and maybe already even, uh, dove into playing with radio sound data. So thousands of places across the world, twice a day, there's an instrument package that's sent up through the atmosphere that's tethered to a helium balloon, sometimes hydrogen. And that instrument package collects dew point, temperature, GPS location, atmospheric pressure. Some packages might have some other fancy instrumentation. It's basically those variables that you're going to want. And so that paints or depicts or actually collects real data of the cross section of the atmosphere from the surface all the way up to the balloon pops, which can be sometimes 60, 70, 80,000 feet. And then that instrument package has got a parachute on it and it falls back to Earth. And they're all over the place. So
I've never found one.
I know, isn't it weird? So twice a day, these things are going up. I don't know how so 30 years ago when I was an undergrad, I was an intern at a local weather service office, and that was the job they gave the interns to
You
do.
you released the balloons.
Release the balloons. And this was our particular forecast office had a hydrogen tank. So if you can only imagine this no, I was a college kid filling a balloon with hydrogen. I still can't believe I'm pretty sure it was hydrogen. Maybe I'm not thinking of that
Was
correctly,
it
but
nitrous?
well, it wasn't. No, I mean,
No, I'm
I
kidding.
think
I'm
it
kidding.
was,
I could see you at like Fish shows or Grateful Dead shows.
well, yeah. Well, that would have been way cooler. Hydrogen had all this like Hindenburg explosive characteristics to it. The way you filled it like way off site too. That's what I remember. It was so far away from the building because I think if it exploded. Anyways, you release this, and so these instrument packages had a little return address on it. So you're supposed to drop it in the mail and they get them back. I don't know where all these are. Anyways.
Nowadays, if Musk was doing this, he would like direct him back to the launching area.
Yeah, it's right. Well, right. They should have little thrusters on the bottom of them and return to where they sent off. So, but these data are really, really important because they give us a depiction of basically the instability in the atmosphere. And so we obsess during the monsoon season about how much moisture there is at the surface and what the temperature profile is. Because a lot of moisture at the surface and a steep temperature profile means those cumulonimbus clouds are going to pop really, really quickly and give us lots of rain and those kinds of things. So to your point about Yuma, I think, and we used to have some more common, I don't know, there used to be balloon soundings I think at the Marine Corps Air Station down there, and they're not happening this summer. They happened all the way up into June. But I think that area is capped. And so capped means that as you go up in the atmosphere, the typical decrease in temperature from the surface as you go up in the atmosphere slows down or even reverses slightly. It really slows down. And so that little perturbation in the temperature profile limits the ability for parcels from the ground to kind of reach a level of called condensation. And so those base of those clouds. And so you end up having very, very humid environment and lots of potential energy to have explosive thunderstorm development. But I think that the thermodynamic profile isn't favorable for releasing it. And I don't know this well enough, but I think it has something to do with being in proximity to the very dry air, to the desert, to the west. And then I know marine environments can create their own kind of thermodynamic profile that will cap as well. And so the only time you see, Zack, to get those thunderstorms is you have to have really deep outflows that come from the east, kind of wedge themselves into the low desert, and then that can provide the lift and break the cap, and you can get those thunderstorms. And tropical storms too. Tropical storms, as they move up through there, they change the thermodynamic profile and eliminate that cap as well. I think that's what's going on. Hopefully, if I'm way off base and it's not a cap and something else, then please let us know.
But I'm glad you talked about this because this is actually part of the thing that I've been learning a little bit more about. It's part of my lifelong pursuit of trying to understand that thermodynamic figure, which, by the way, there is no figure that I know of that is more complicated. I've said this before than the SQT, but it's amazing, right? Like on that one figure, you can basically understand the thermodynamics of the atmosphere, right? Like severe storms, like tornadoes, hail, like severe winds, turbulence. Like it's pretty spectacular. But there's a component of it called convective inhibition, which is basically the energy that would be required to lift the air near the surface to a level where it sort of is buoyant, right? And so it can freely go up in the atmosphere and form these big giant convective storms that rain out. This is part of severe storm meteorology. So it's called convective inhibition. And it's usually a function of what you talked about, this cap, right? Like this, or like an inversion, right? That prevents, right? It's like a stop in the atmosphere that prevents like all of the warm air that is forming, the warm, moist air from forming. It's actually colder than what's above it, right? And so it doesn't rise like a hot air balloon. And if you have big enough caps, you don't break free and you just generate a bunch of like warm, soupy air in the bottom. And so, yeah, like to your point, like you actually need a mechanism, a strong mechanism. And if you have a really severe cap, like you need a really strong mechanism to push that stuff forward. But it's also like really important for producing, even in Tucson, like producing like severe storms. If you have a little bit of a cap, right? And so you build up all of that potential energy below us. And then if you do get these outflows, or maybe there's some other feature that comes comes through, or maybe it's just like really hot heating convection going on, and it breaks that cap, boom, you get a massive like thunderstorm that pops off. So convective inhibition is the thing that been paying more attention, because it really is like a function of like, well, is it going to be a massive severe storm, severe thunderstorm, or not? So that's what
Well,
I'm.
yeah, that it's I know, and that's the things that we talk about from season to season kind of vary. So like this would be the season, well, especially now the last week or so, the convective inhibition, is a function of it can be a function of previous day activity, can be in function of the monsoon ridge kind of moving around. There's really interesting features that can emerge from nearby topography, can kind of change the thermodynamic profile from a nearby mountain into a valley location. And to your point, Zach, the cap can be really important to delay the onset of convection until you get some kind of forcing mechanism. And so this is where the thunderstorm activity around Tucson the last week has been outflow driven. And so when we talk about outflow driven, it means that there's some kind of cap, probably at the top of the mix layer, which is the where all the churning is going on, and
Near the surface.
near the surface. And so you need a thunderstorm that typically occurs. So there's not much cap on it. Sometimes there's often no cap over topography, because it sticks up into the atmosphere and it intersects the thermodynamic profile above where a cap would be. And so that's why you can see thunderstorm convection bubble up really early in the morning and just kind of do it all day long. And where it's completely clear in the valley, it means that there's probably a cap. And so that thunderstorm activity will put down rainfall, and that cold air that rushes out from that rainfall can act like a little mini cold front. And so it will start to shove air up. And if it's mechanically pushing through that cap, and then it can release that energy and you start to see the thunderstorms billow up. So that's actually what happened across Tucson last night. Was very, very weak steering flow, thunderstorms popping up in the mountains, and then the outflows were just kind of all over the place. Storm turrets kind of coming up in every different way until it exhausted all that and the sun went down and we were kind of over and done with the convection.
So I think this also happened on Sunday.
Yes.
So I was sort of in Tucson. There was a really severe storm cell. We got at our house an inch and a half, but part of that was like ping pong sized hail. And referencing again the sort of forecast discussions that are put out by what is it? Our colleagues. What I want to get the name right. The power forecasting group.
Oh yeah.
I joined a webinar. They showed this radar loop. There was these cells that were coming from the east of downtown Tucson toward the west. And then south of that, there was cells that were popping off that were generating these outflows. This is sort of the forecaster sort of guess. I mean, but I think it illustrates the point. And those outflows were moving north and collided with the rain and convective cell that was basically over my house. And it further, it just contributed more to the lift and generated what ended up becoming a really powerful, 15 minutes of rain and hail. So I think that's an important feature of it's not only important to generate these cells, but can also sort of accentuate when you have the collision of outflows.
Absolutely.
All right. So we've been at this a long time. I told you it was going to be a long one.
You're going on and on. Yeah.
All right. Let's end this really quickly with the what next. Okay. So we're mid July, 2/3 of the way through July. We've got a lot of monsoon left, man. But what's the word for at least the next couple weeks in August?
I don't know. It doesn't. it looks like more of the same.
In
So,
in the near term or throughout August as well?
well, just for the next couple of weeks, the there's a little bit of there's a lean across the southwest towards a, above average precip on the week 3 forecast that would put us through first, second week of August. And so first week of August is prime time monsoon across the southwest.
It's
Like
the
that's
peak of the precipitable water.
peak
Yep.
of precipitable water. It's usually the peak of precipitation, and it's kind of like you build to that, and then you start to you're on the downward slide of the monsoon past that, and so that's leaning above average. These models really struggle out at that time scale. The the 8 to 14 day outlook is actually below average for much of the Southwest. So I don't really I don't know, Zach. Like I feel like there's a lot of potential here, and hopefully there's just a couple of one or two or three weird little like embedded fun things maybe could change that dynamic. But if we do what we're doing right now, we're going to end up having this really kind of spotty, isolated, flare-ups of thunderstorms across the Southwest for the next couple of weeks, and it won't be huge at building precip totals, but some places like your house might get 2 inches. A lot of places might not get anything, and we'll just have this kind of messy march towards hopefully average precip.
I gotta repair my roof for hail damage.
You better get out there.
Looking at the month of August, I'm looking at the National Multi-Model Ensemble, and this is very similar
I know,
to
yeah,
a month ago when we did our last podcast. All of the models are showing a dry sign.
yeah,
And the International Multi-Model Ensemble is showing a dry sign. So they're very bullish on below average rainfall in the monsoon region for August.
yeah. They were wrongish. I don't. It's hard to say they were completely
They
wrong.
were wrong for the wrong reasons.
That's kind of right. I think that's the right way to say it. And we'll have to do a little bit more of a post-mortem or a deconstruction of what they.
Can you be
I still
wrong for
don't.
the right reasons?
Can you be wrong for the right reason? Probably. That's a more philosophical question. Or
Anyway,
that sounds like a weird like Hallmark
I
movie.
think like when we turn our talk to like forecasting the monsoon, it should dive into philosophy and
Yeah, yeah.
ethics and morality
I
and maybe
agree.
even politics.
Maybe. Oh, let's not do it. I don't know. Yeah. Is it
All
moral
right.
to even forecast the monsoon? Maybe that's the question for next podcast.
All right, we're gonna throw our hands up for
All
for
right.
for I mean, what let me I always ask you this, like,
Yeah.
are you optimistic or pessimistic?
Um,
Let's
you
let's
know,
say for the next 6 weeks.
I
Let's
actually
say
am
for the end
optimistic.
of no, let's say for the end of July.
I'm optimistic. I,
What
I
about
am.
what about for August?
I'm pessimistic.
Interesting. Okay, so you're actually following the models.
I kinda am.
Yeah.
Well, I'm following the short-term models and the long-term models. Yeah. Yeah.
I
Yeah.
yeah, I would say I'm very similar to that actually. But I'm burned on the July forecast because I'm on the record as repeating like these models and feeling like if there was a year where we should believe them that this is the year because they were all saying the same thing. And
I know, right? And I mean, but they can't get what happened. And I think
yeah, they
if that Alberto didn't happen, then they probably would be closer to being right.
yeah,
I think that's right.
I think that's right too. And we're going to end it with that. So thanks, Mike. I appreciate it. That was a great discussion. And thanks to Stacy Reese for producing this and the power forecasting group for doing the cool monsoon blogs and just everybody's interest in the monsoon. It's really the coolest thing that I get to talk about all year. So
Can I
thanks,
can I say
everybody.
real quick too, Zach, that why am I 419th in the monsoon fantasy? I have 0 points.
Do you see I didn't check mine today. Did you see where I
I
am?
don't know. All I know is that I have to scroll way down.
Because last night the Tucson airport got a little bit over a half an inch. So I think that changed things.
Ugh.
You can't see me. I'm not in the top 20.
I am not either. Oh boy, this is going to be ugly.
All right. Well, everybody
Thanks,
have a
Zach.
great rest of the July, and we'll come back sometime in early to mid-August.
Absolutely. Thanks, everyone.
Thanks, everyone.